Hey guys, welcome to this AP Statistics College Board example. So this is question one. It says an online company is hoping to sell a new product by placing a pop-up advertisement on their website. There are two different designs for the advertisement and the company would like to determine which is more effective as measured by clicks and purchases. For the first 200 visitors to the updated website, half were randomly assigned to receive advertisement one and half were to receive advertisement two. So anytime we have a random assignment, we know that this is an experiment, okay? So the two-way table summarizes this. So we have did not click, or you clicked and no purchase, clicked and made a purchase, okay? We have advertisement one, advertisement two. It says, is this study an observational study or an experiment? Explain. This is an experiment because the stem of the problem states that half of the visitors were randomly assigned to receive one of the two advertisements. So you can also include just, I think this is good, but an experiment has random assignments and the treatment, and so that's what makes something an experiment. So next one, it says provide one piece of evidence why advertisement one is more effective. Okay, well, advertisement one, 70 people didn't click on it, but because you want to try to show why advertisement one is better, you're going to talk about this part here. There's 30 who clicked on it in total. 22 made the purchase. Okay, so that's a lot. So 30 people clicked on it, and of those 30 people, it's a given, okay? It's a conditional probability. Of those 30 people, 22 people purchased this. So look what I wrote over here. Of 30 clicks, there were 22 purchases. In other words, given that they clicked on the advertisement, advertisement one, there was a 73% chance of purchasing the product. So that's great, okay? So that shows that advertisement one is great. Advertisement two, I was trying to figure out what's the best thing to do here. Well, if you take a look at advertisement one and advertisement two, 70 people didn't click, 64 people did not click. So you got more clicks, right? So this is going to give you 30 clicks. This gives you 36 clicks. So I just said more people click on advertisement two than advertisement one. If you take a look, 16 out of 36 was about 43%, I believe. And so you don't really want to use that as why advertisement two is more effective. You just want to say something quick, okay? So I think that's more than enough to write, all right? So more people clicked on advertisement two than advertisement one. All right, letter C. Letter C says, one customer from the study will be selected at random. Are the events advertisement one and made purchase, are those events independent? Okay. So I have here, advertisement one and made purchase. So I hope everybody remembers how to determine if two events are independent. In order to determine if two events are independent, we must take the product of the two probabilities separately and see if it's equal to their intersection. So I said, does the probability of advertisement one times the probability of making a purchase equal to the probability of advertisement one and making a purchase? You guys can pause the video at any time and try stuff by yourself, okay? So advertisement one was 100 out of 200. Click made purchase was going to be 38 out of 200. So that gives me 0.095. And their intersection is basically where I cross here and here out of 200. So 0.095 does not equal to 0.11. They have to match perfectly, okay? Since the probabilities are not equal, the two events are not independent, okay? So that's how we do that one. Now let's try letter D, E, and F. The online company conducted a test of a hypothesis. P1 equals P2, right? Or P1 minus P2 equals 0. P1 does not equal P2. Okay, where P1 is the proportion of customers similar to those in the study given advertisement 1 that would click and make a purchase. And P2 is the proportion of customers similar in those study who, I'm trying to do something simultaneously as I'm reading, so that is what I was trying to do, get rid of that noise. So it says P2 is the proportion of customers similar to those in the study given advertisement 2 that would click and make the purchase. The conditions for the inferences are met. One of the conditions for the inference was n times p hat, n times q hat, or 1 minus p hat are greater than 10. Explain why this is necessary. So I just wrote here, in order to assume the distribution is approximately normal, we need np hat and n times 1 minus p hat to be greater than 10. I think that's good to go. The test resulted in a p-value of 0.2795. It says interpret what the p-value means in the context of the study. They're not asking you what conclusion should be made in letter E. They will in letter F. They want to understand what a p-value is. So if you recall, especially my students, p-value is the probability of a test statistic being this extreme or this large or larger, okay? Or this or more extreme. So let's look what I wrote here. I wrote the p-value of 0.2795 measures the chance of observing a difference between the two sample proportions. Okay, that's these two guys. As large as or larger than the one observed, comma, assuming HO is true. So if the proportions are in fact the same. Okay, so it says interpret what the p-value measures in the context of this study. So the p-value measures the difference, the chance of observing a difference between the two. So basically determining if the two proportions are different based on the advertising. So this, I think you guys should either understand or memorize or something, but it's very important to understand how to interpret the p-value. And then letter F says, based on the p-value, what conclusion should the online company make? Well, because the p-value is greater than alpha equal 0.05, we failed to reject HO. We do not have evidence to suggest that there is a difference between the two advertisements. Okay, so that's this problem. I hope everybody learned. Press pause, jot down notes, do whatever you have to do. Good luck on your exam.